Hey gang, welcome to year 2 of Code Club. This year we're going to learn how to program a game in JavaScript, one of the most prevalent programming languages in the world. This isn't going to make you an expert in JavaScript, but hopefully it teaches you enough so that you can go out and learn some more on your own. In week 1 we're going to learn some basic concepts of game programming and do a little coding to get our game started. Open up another browser window so you can follow along. Have fun and let's start coding. The goal of these sessions is going to be to build a web-based platformer game that looks something like this. It's kind of like Donkey Kong or Mario Brothers. If I go through and play it real quick and turn the sound on so you can hear too, and go through and play it real quick. You pick up coins, you get a key, then you come back. If you have the key, you go through the door. And then, there's levels where there's enemies that are little spider-looking things, and you can go and you can try and hurt them, but they also hurt you, make you restart the level. So this is what we're going to build up. And the way we'll do this is we're not going to be able to build the entire game at once. That would be way too much work. So every week we're going to build little pieces of it so that by maybe about week 5 or 6 or so, you'll have something that's pretty usable. And by the end of week 7, you'll have a game that's fully playable. And then week 8, we'll add on some cool extra enhancements and type stuff like that to it. If any of you were in Code Club last year, you'll know that we used a programming language called Scratch, which, while it's really cool and it can do a lot of stuff, the more things you want your program to do, the more complicated your Scratch program becomes, and you wind up having to pull lots of blocks in all over the place, and it's very difficult to keep track of. So typically, if you want to do some advanced programming, like a extensive game, you want to switch to a different programming language. For this year, we're going to use a programming language called JavaScript, and a helper framework on top of JavaScript called Phaser.io, and another helper called Json that lets us store data about our game. And the point of these sessions isn't going to be to teach you JavaScript, or to make you an expert in Phaser.io, or make you an expert in Json. It's to expose you to these other concepts and how they fit together, so that once you get through this, you can say, okay, I made this cool game, but now let me go actually learn JavaScript so I can start making tweaks to it. As a little quick bit of background, JavaScript is used by most websites in the world. It's supported by almost every web browser. And basically it's used when you want to program something on your website. You can change what your site looks like or sounds like, or the videos on it, all sorts of different stuff with JavaScript. Usually you need a bunch of helper type of functionality on top of JavaScript to make it work well. So if you want to interact with a web page, you use a framework to do that. Since we're going to be doing a game, we're going to use a game-specific framework called Phaser.io. And, at their simplest level, a framework is basically, it takes a generic programming language and adds features that make it more specific. So Phaser.io, the framework, extends JavaScript to make game programming easier. So that's why we're going to use it. Json is another thing within JavaScript, and really you can use it with any language, but it's very popular with JavaScript, that allows you to store data about your program and then retrieve it later. So it's very good at, it's formatted in such a way that it's very easy to read into JavaScript, and then once you have made changes to your data, you can write it back out to disk very easily from JavaScript. Data is basically the information you need to make your program work. So for our game, we'll need things like the layout of the level. Where are all of these platforms? Where are all of the coins? Where's the key? Where's the door? Where's the spider? All those things are data about our level that needs to be stored. And we're going to use JSON to store that. Now, all these languages and frameworks and data storage formats, they kind of make it a little more complex. It's certainly more complex than how we had to do things in Scratch. So to do this, you typically need what's called a development environment. And basically, it's a place to put our code and run our code when we're testing it. Because we're doing web-based programming, the basic components we would need are a web server, a file editor, and a web browser. And the web server is where your code would run. A file editor is how you change your code. And a web browser is how you look at the results of your code. There are lots of ways to do this. We could set up a web server on our computer and then use Notepad or something to edit things on our computer, and then use Chrome or Internet Explorer, whatever you have on your computer, the web browser. Or we could pay somebody to host the web server for us and then move files up to this place where we're hosting it. Or you could do what's called cloud-based development environment, and it's basically the same as the having somebody host a web server option for us, but usually it's easier to set up and sometimes offers more features. Scratch is probably technically a cloud-based development environment, but remember, it has a lot of limitations about what you can do with your program unless you want to have a really complicated Scratch program. So to make things easy and consistent for us, we're going to use what's called Cloud9. It's a cloud-based development environment. It gives us the web server and the file editor, and then we can just use the web browser that's on our computer in order to view our code. So I created different videos that show you how to sign up for Cloud9, and there's two videos, one for if you're an Ardmore School Code Club student and one for if you're not, because the process is going to be a little bit different. But once you need to use it, it's pretty much the same. You go to c9.io, and if you're not logged in, you go ahead and click the sign in button right here, and you put in your username and password. And then it'll bring you to your home page. And this is what mine looks like right now. I got a couple of test environments that I've been playing with, and I changed my picture and stuff like that. The main thing we're going to use in this part is called Create a Workspace. If I click on Create a Workspace, it's going to bring me to this new page where it asks me some information about my workspace. And so, it wants a workspace name, which this has a few requirements. It's basically can only be lowercase characters, no spaces, no capital letters. I think you can use numbers, but no special characters. So I'm just going to use something simple. I'm going to say platformer game. No spaces, no uppercase letters, nothing like that. And then the description, you can be a little more freeform. So I'll say platformer game with uppercase letters and a space in there. For the team, if you're actually in the Ardmore 5th grade code club, choose that as your team. Otherwise, you probably won't even have anything to put in there. For Claude from Git or Mercurial, you're going to want to paste this URL in. It's in the YouTube comments below. And basically what this does is it's going to set your workspace up with some default stuff that I created already and I stored in GitHub for you to copy. And what it's got in there is things like the images and the sounds that we're going to need for our game. It's got a copy of phaser.io, so we don't have to worry about setting that part of it up. It's already set up. And it's got like a basic folder structure so that we can start working without having to do a bunch of other setup work other than creating the workspace. It's going to copy all the other setup stuff in for us. Before I click on Create Workspace, if you're the curious type, you might be wondering what clone from Git or clone from Mercurial means. And basically, Git and Mercurial are what they call a version control system in the programming world. And it takes the code that you're working on and you tell it to push it up to a server, and then that server keeps a history of every time you've pushed code up to there. And if you're working on a team on your code with multiple different people, all of the other people on your team can also push their code up there, and then you can pull the code down and look at other people's code and stuff like that. So it's a way that lets you, store your code somewhere remotely, kind of like a backup, but then also see the version history of everything you've ever done and share your code with other people. And that sharing feature is kind of what I'm doing here, is I have what's called a Git Repository for the Grade 5 Code Club, and I have some code in there, and we're going to copy it down into your workspace so that you don't have to do a bunch of pre-initialization work on your workspace. It's already done for you based on the code that I put in that Git repository. I'll click on Create Workspace now. Let's see what happens. So it's saying creating your workspace. And this is going to take a few minutes. I'll probably stop the video at some point and restart it. Okay, so we're back. This is what it looks like. And you can kind of see over here, there's a little File Explorer window. There's a kind of README file here. All this stuff over here is stuff that I created. That's where we pulled this stuff in from the Git repository. And then this README file is also something that I created. So other than the File Explorer window here, you kind of have this big open window here. And that's where, when you open a file, so if I double click index.html, it opens that file up. And this is where it lets me edit it. The other main file we're going to use is actually called main.js. So I'll open that up too. And that's blank right now. And, I can type stuff in there, whatever. I'll delete that because we're not actually going to use it. But these editor windows are kind of the main interface. And then the last thing is this preview button here. Let's just say live preview file index.html. And that opens up a new window with what the browser sees when they look at our files that we create. I'm actually going to pop this out into another window. That way it's easier to tell what's going on as we make changes. So I would say these are the main windows we're going to use here are this file explorer as we browse through the different parts of our game, and then these text editor windows, and then the preview window for our game, which is blank right now because there's nothing in our JavaScript file. Now that you know the basics of how Cloud9 works, we can go back to the index.html file and actually start looking at some code. Now the index.html file is what actually loads up our game, but we're not actually going to have to do any editing in here. This is one of those things that got copied over as part of the Workspace creation, and I pre-created the stuff in here. So I'm just going to run through real quick what it does, but you'll never need to change anything in here. The main things are, if you look at these two script source lines, the script keyword in HTML is what says load some JavaScript up. So the two things we're loading are phaser and the main JavaScript file for our game, which is where we're going to put all of our game code. The other important line is down here in this div ID equal game line. And what that does is tells the HTML code, this is where we want our game to be. It's the area we're going to put our game. And if you notice, it's blank right now, and that's because we're actually going to use the JavaScript code to push things into that area. If you look right now, our preview for our game is blank because we're not pushing anything into it. If I were to type some stuff in there manually and save it, now the preview says hi there because I told it to put that in there. But we don't want that. We want some cool game code in there. So I'll take that out of there. Our preview goes back to nothing, and we can start doing some coding. So the one other thing you need to know about our environment is I created this folder called weekly, and in there is a JavaScript file for every week of the sessions that we're going to have. And each of those contains the code for that week session. So as we start doing some coding and you're looking at the videos, if you don't feel like switching back and forth between the video and typing in what I'm doing, you can kind of copy and paste code out as you need to. And that will just make your life easier. So if you're following along and you want to copy and paste some code without having to type it all in, it'll be in those weekly JavaScript files. So to start doing some actual coding, we need to flip back to the main JavaScript file, and we'll put the first part of the code in there, and it's this window.onload function. And what that's saying is every time the index.html file loads, it's going to run this window.onload. And that means it's going to create a phaser game and start playing the phaser game. That's what these 3 lines of code do. Window.onload is a special JavaScript function that actually says every time my window loads, do something. And then a function is just a group of related code. And these 3 pieces of code create a new phaser game and start it playing, so they're related code that we put together into a function. The other important thing that these functions can have in JavaScript is called parameters. And a good example is here where it says new phaser.game. So phaser.game is a call to a function, and the function does something, and what it does is create a new phaser game. And then you pass in these parameters that change how that create new game function works. So the first 2 change the length and the width of the phaser game. The middle one we don't need to worry about right now. But then the last one where it says game is very important because that tells phaser the name of the area in our HTML where we want to put it. So if you look here, this says ID equal game. This has to match what's in the main.js, and that's where it's going to create our phaser game for us. Now if we save this, either by going to File, Save, or by clicking Control S, and then we go to our preview, we can see that the preview now has, instead of the white window that it had before, it's got kind of a white window with a black box inside of it. And this black box is our phaser.io canvas. And right now, because we're not loading anything else other than the game up, We're not loading any images or sounds or anything like that into it. It's just a black screen, a blank canvas for us to work on and create our game. The first thing you need to do when you create a game is set up what's called a game loop. And basically, this is the heart of the game. It gets input from the player and then updates the game world based on that. So it's got a bunch of variables that store the status of everything in your game world. Where your character is on the screen, what your score is, where all the enemies are. If you have to, we're making a platformer, you jump around to different platforms, where all the platforms are. We're picking up a key and going through the door. So it updates where those things are, and then whether you have the key or not, that kind of stuff. So everything about your game world gets updated, possibly based on your user input, and then it renders a new version of the game world, which means it spits out all of your graphics and stuff on the screen and the sounds and everything that gives feedback to the user. And it does all this incredibly fast. My explanation there probably took 25-30 seconds, but it's actually doing this update ideally 60 times a second. And if you ever play a game like Minecraft or some games like that, when you're playing it, it kind of slows down a little bit. When those slowdowns are happening, it means that this is dropping significantly, and if it drops below about 24 frames a second, that's when we kind of start seeing the blips in the graphic that make it look like it's stuttering and stuff like that. In the computing world, this type of game loop is typically implemented using what's called a finite state machine. And a finite state machine is basically a group of code that can be in any of one state at any given time, and then based on some sort of input, which they call conditions, the state can change to another state, and that change from one state to another is called a transition. So if you look here, we have init, preload, create, update, render, shutdown are all possible states. And then you have transitions. You can go from init to preload, from preload to create, and these changes happen based on some criteria. And then if you look in update and render, this is where our main game loop is, and it goes back and forth at 60 times per second. And then at some point that initiates a shutdown of the system as well. Luckily for us, we're using Phaser.io, and Phaser.io has a built-in finite state machine that handles the game loop for us. We don't have to go and do a bunch of state machine coding. It has built-in functions for init and preload and create and update and render and shutdown. And update and render are where the game loop happens. If you look, it's got a little loop in here for 60 frames per second. So any code we put in update, any code we put in render is going to be run every frame when Phaser loops through the game loop. That's enough theory for now. I'll switch back to code to kind of show you how to implement this within Phaser. So the first thing we need to do is tell JavaScript that we need a place to store our playstate, and we're just going to call it playstate to make it super easy. And it says var playstate equals, and this is saying there's a variable called playstate. It's going to hold some objects in it, and the objects are going to be the functions that handle our playstates. When we created the window.onload function before, there was these two lines in it that I didn't really explain. But now that we understand game states, they make a little more sense. This first line is basically telling Phaser.io our state objects are going to be stored in the variable called playstate. And then the second line says start up our playstate. But since we don't have any other code in our game yet, it doesn't actually do anything. If we, save this and look over at our preview, it's still just a blank screen. The last code we're going to add for today is the preload and create states to our game. And we'll use the preload and create to make a background image on the game. So it's not just a blank image, it'll be an image that we give it. And if you remember, part of the pre-made template that I gave you had a bunch of images in it. And you can see right here, one of them is the background. I'll paste the code for the preload and create game states in and then walk you through how they work. The first thing I want you to notice is that in both preload and create, I use this.game. And the reason for that, you're going to see it a lot, is because this .game is the reference to our Phaser game canvas. Up here, we created a game canvas and we named it game. Everywhere we want to use it, we're going to say this.game so that we can reference it. Preload and create are both built-in game states in Phaser.io. So what's going to happen is when the game starts up for the first time in a window, it's going to call preload, and then it's going to call create, and then it's going to go through the main game loop. So both of these things only happen once. In preload, it's doing what's called loading the image into the game cache. And so you can see it's calling load.image, and it's passing in the image file I showed you before. And this part gives it a name, and the name it's giving it is background. This doesn't actually make the image print out on the screen. All this does is loads it up into the computer's memory so that we can use it later. The reason we want to do that is because typically in a game, you're going to use an image or a sound or some of the other different types of things we can load into the game cache multiple times. And if you had to load it off of the disk every time that you needed it, that would make your game very slow. So preloading them all once, putting them in the computer's memory, makes your game much faster. Now if we look at create, this is where we actually tell Phaser to print the image onto the screen. And what we're saying is add the image called background, so you had to have loaded an image called background already, into the coordinates 0, 0. And basically the way Phaser works when you want to load images or other things that you would put on the screen is you give it an X position and a Y position. If you remember like a graph from math class, that's where the X and Y line up. So 0, 0 for Phaser is the upper left corner of the screen of a coordinates graph. The other thing I want to warn you about here is that sometimes the order that we put code in JavaScript is important. For example, here we're saying var playstate at the top, and then later on, we're saying playstate.preload. Well, if we hadn't put that var playstate at the top, if we put it at the bottom instead, underneath these, saying playstate.preload would fail because JavaScript doesn't have any indication of what playstate means yet. The same thing up here where we're saying let game equal new Phaser game, and then we say game state add. If we hadn't said let game equal something first, it wouldn't know what to do with game state add and game state start. Finally, we're at the point in our coding where we have enough code in our game that it should load up the game window and put our background into it. So let's save what we added here, flip over to our preview, and hey, now we have a background. We still can't do anything with it yet. That game loop of update render is basically doing nothing. It's running super fast, but we have a background. Next week, we'll start looking into adding some other things to this so it'll be a little more interesting. Okay, that's it for week 1 of Code Club Year 2. I hope you enjoyed it. See you next week.